All right, in our last video we talked about what an acid is and what a base is, but we're more concerned with actually how that measures up and what it actually does. What we actually use to measure pH or measure the acidity of a substance with is the pH scale. Here's a list of common household bases and acids and what they might be used for. What this list does not give us is some type of way of measuring which one can cause more damage and that type of thing. And so that's where the pH scale comes in. Here's an example of a pH scale. And what you'll note are a few things about this. One, the scale ranges from 0 to 14. The acids make up everything less than 6. So acids are less than 7. Your neutral substances are going to be equal to 7. And anything that's going to be greater than 7, your bases, will be greater than 7. So bases will range 7 to 14, acids will range 0 to 7, and neutral substances will be right at 7. The extremes of the pH scale, meaning the tops and the bottom here in this particular picture, are not necessarily super concentrated or unconcentrated. What they come down to is most acidic or least acidic. You could say that an acid is the most acidic at 0 and a base is most basic at 14. What you could also say is that a base is least basic at 0. And so there's a range. All of these substances will produce both H plus and OH minus when you put them into water. However, an acid has a much greater percentage of H plus ions in water, and a base has a much greater percentage of OH negative ions. Here are the equations that we're going to use to calculate out pH, pOH, and the reciprocals of those. We're going to be focusing on the concentration of an ion. Now remember, we learned already the unit of concentration that we're going to use is molarity. You will be given a value for the concentration of the hydrogen ion when it's placed into water. That value is almost always going to be to a power of -10. And the reason being is we're talking about the number of those particles in the great solvent. So remember we discussed in class how solutes make up a much smaller percentage than the solvent in solution. And though we're using the logarithmic button in these equations, it really is quite simply the matter of just pushing the button. And so we'll work with this equation in class, and we'll work with it through this video. But the important thing to note is if you are given the hydrogen ion concentration, and you were to take the negative log of that, you're going to get the pH value, which refers right back to this scale that we're looking at here. There's also something called the pOH value, and the pOH value is the opposite of the pH. So if you're given the hydroxide ion concentration, you're going to be solving with negative log to find the pOH. Well, those two values, pH and pOH, always add up to the same number, and that's 14. Also, because water self-ionizes at a constant rate, the hydrogen ion concentration and the hydroxide ion concentration together always multiply out to the same value. These are all helpful equations in solving pH problems. Over here on the left, you have a chart of the different things that you might have to do with pH. If you're solving for H plus ion, you're here, OH ion here, pOH, and pH. This is very similar to some of the other maps that we've used in class, and all it does is call on this set of equations provided. So let's try a few pH problems. If I have a hydrogen ion concentration of 1 times 10 to the -7th power, and I want to solve for pH, what I would have to do is I would have to take the negative log of 1e -7. And this value comes out to a pH of 7. Because I was given the hydrogen ion concentration and I did the negative log, the answer I get was pH. The same thing would also apply for the next problem. 2.3 times 10 to the -10th power gives us a pH value of 9.64. Now the last problem here is a little bit tricky. You're given the hydroxide ion concentration here, but you're asked to find the pH here. So I pose this question to you. Is this a single step problem? is there a direct translation from hydroxide ion concentration to pH? And the answer is no. The easiest way in my mind to do this would be to take the negative the negative log of the hydroxide ion concentration, which is 3.7 e to the negative 12. The answer you get from this is 11.43. However, this is not the pH value. This is the pOH value. So we performed a single function and took us down to the pH. Well, to get from pOH to pH, we have to take 14 minus that number. So 14 minus 11.43 gives us a pH value of 2.57. Let's go back and try and classify each of these substances. In our first problem we ended up with a pH value of 7. According to our scale, that means that this is a neutral substance. Our second problem, we got 9.64. According to our problem, again, or our scale, that would make it a base. And the final one we got was a pH value of 2.57. Looking back, that's an acid. Doing much more practice with this in class.